concentrations are very closely related to density. Okay, some of them say, people say, can go hand in hand. Okay, density is all about how much mass is occupied in its space. Hello, Huey. Can you say hello to everyone? So if we're dealing with space, and if we're dealing with the weight of something, okay, then we are typically dealing with the density of it. Okay, so when we have density, we might see that on a lot of different types of quizzes and tests and big tests that it comes across. Density is usually more commonly talked about than concentration is, okay, since concentration is just our ratio of solute to solvent. But a lot of people might use the term density to talk about that something is more dense than something else, or if it has a lot of different types of liquids, you might often talk about density. And we will be finding the different densities of liquids and solids in class. Okay? And hopefully that will kind of help us distinguish density and concentration. Now, we can, as I said, find the density of a solid, and we can find the density of a liquid. We just need to know two things. We need to know what its mass is and what its volume is. Okay? And when we're thinking about mass, all we are thinking about is how much it weighs. So we have to be able to weigh it in some way. And when we're thinking about volume, we are thinking about how much space it takes up. Okay? And we can do this with both solids and liquids. It just, for each one, you have to do kind of a different step and a different process. For solids, when we're looking at mass and volume, mass is super duper easy to find because all you have to do is put it on a scale and weigh it. But when we go to volume, that's when you have to get into a little bit of math and do the equation to find volume. When we're dealing with liquids, the mass is the trickier step to find. Okay? When we're dealing with liquids, you actually have to subtract the weight of the cylinder, okay, in order to figure out how much the liquid inside weighs. Now, yes, hello. Now, the volume, however, with liquids are super duper easy to find because all you have to do is read how much you have inside of your graduated cylinder. Okay? We're going to talk first, we're going to focus our discussion first on liquids. Okay? Now, you guys found the mass already today in class, and you know how much volume you had to work with. So we're going to do a couple of practice problems here together. But before we go any further, I want to, since Huey is loving my notebook here so much, I want to talk about a way to help you remember how a density equation is set up. Well, we want to think that everybody loves density so much that we don't want to break density's heart. Because if we were to break density's heart, then we would end up with an M on top and a V on the bottom. What does the M stand for? Mass. What does the V stand for? Volume. That, goodbye Huey, that hopefully will help you to remember that the mass always goes on top and the volume goes on bottom. Now let's talk about one other thing. Our label for all of our density problems that we're going to be doing in class is going to be grams per milliliter, okay, because that tells us how much weight per space that we're working with. Okay. Let's take a look at a couple of the concentrations that you made in class. You made a concentration of 8 grams of solute to 20 grams or 20 milliliters of solvent. And then we're looking over here at our mass of 20 milliliters. Okay? And 20 milliliters of this concentration weighed 21.8 grams. Okay? And how do we go about figuring that out? Yes, Huey. She always wants to be in this here. She's so excited about the video today. Okay? What we're going to do is we are going to take the weight, okay, that you found by calculating out, Huey, calculating out how much the liquid weighed, all by itself, which was 21.8, and the amount that you had was 20 milliliters. So all you have to do is set this up like a math problem using our equation. So we're going to take our mass, 21.8 grams, over 20 milliliters. your setup would look like this. And then we're just going to divide it out using our calculator. 21.8 divided by 20 is going to give you a density of 1.09. And what was my label again? Grams per milliliters. Whatever is on top, that goes first. Grams per milliliters. There's our answer to our first one. Sometimes with density you can find the same sorts of things. If you look carefully at the next recipe, you had 16 grams of solute and 40 milliliters of solvent. Now you took a 20, yes, hello Kiwi. She wants to be a movie star today. So, you're taking 21.8 grams of a 20 milliliter sample of this solution, and it ends up being the same. So the density is the same, even though it wasn't the same original recipe. Okay? Let's take a look at one more that we can actually work out together. This time we had a concentration of 15 grams of solute and 25 milliliters of solvent. And our mass of 20 milliliters was 23. So how do we set this up? We take our mass, we put that on top, 23 grams. For this situation, everybody was working with 20 milliliters. Okay, 20 milliliters. So we take our calculator and put 23 divided by 20, and that gives us a density of 1.15. With a label of, yep, you got it, grams per milliliters. Okay? Okay? I hope you guys have a good night. I hope density makes sense. And remember, don't break density's heart. Remember that it is always mass divided by volume. We're going to focus first on liquids, and then we're going to move on to solids later in the week.